Good morning.
Good morning. How are you?
I'm good. Yourself?
I'm doing great. Thank you.
Fantastic.
So we're going to get started shortly. Anything that you want from me in special?
No, I think I'm just in the background here, just making sure that your picture is up. So,
Perfect.
yeah.
And I'll look alive.
Awesome. Sounds good.
Okay. Thank you.
Thank you.
Great. So thank you everybody for being here. My name is Arman. I work for an organization called Digital Moment. And what are we doing today? We're going to work with microbits and we're going to work with machine learning. Most importantly, we're going to be exploring Create AI and we're going to be thinking and seeing what are the connections that lead us to work with machine learning. Why machine learning with microbits? What does machine learning do for us? Why is this a different way of learning, of different way of applying concepts, tackling problems, taking advantage of opportunities? Let's take a look at that. That is the idea. So we have four objectives. The first one is we're going to dig deep a little bit to understand computational thinking 1.0 and computational thinking 2.0. We've been working with computational thinking 1.0 for a long time, but this is going to be the foundation of where we are trying to go, and we're going to explore the difference between the two. In the process of exploring computational thinking 1.0, we're going to revisit fundamental concepts of the microbit. So if you don't remember, if you haven't seen them, it's going to be fine. I'm going to be talking through them, and we're going to build a very simple application that is going to help us think, how can we approach one problem? And then what we're going to do is we're going to try and solve the same application, but now using computational thinking 0.0. What are the challenges or the opportunities in doing so, and how can we do it? And then we're going to learn how to use CreateAI. Very simple, very friendly way of working. And what I want to point out is that we're going to do it both with the version V1 of the microbit and the version 2 of the microbit. So if you have V1s, you don't need to buy V2s. Those ones still work great on an educational platform. They're going to be perfect. If you have V2s, then you have extra liberties and extra things you can do. Let's get started. So as I said, we're going to start with computational thinking 1.0 and 2.0. Computational thinking 1.0, we can see it from two different points of view. The first one is the one we've been talking for many years, the one that invited the first concept of teaching everybody about coding. And nowadays, it's not about making developers, about everybody becoming a developer because we learn a computer language, but to give us a framework, a way of thinking, a structure that is going to help us and our students to tackle problems and opportunities. And that we know that starts with the composition. Have a big problem, we break it down into smaller problems that we can tackle. We feel motivated, energized, and we start finding solutions. As we start solving smaller problems, our problem starts becoming less of a problem and more of an opportunity. In that process, we identify patterns that are going to help us optimize our solution. Try to find patterns that we apply from one problem to the next, to the next, to the next. Then we abstract that solution because, as I said, the solution doesn't have to live over only for this problem and opportunity, but we can apply it in many different other scenarios. So if I make an abstraction, then I know that if I have this opportunity, maybe I just need to change or tweak a few things and I can solve different situations. It helps us and our students to tackle these situations. And at the end, we create an algorithm. I want to make dinner, then I don't know how to cook, but maybe I take a look at what I have in the fridge and I start going over the process. At the end, I have a recipe of something that is not going to kill me or maybe taste even good. We can see the other part if we're thinking from the point of view of creating a program, is that if we have that problem or opportunity that we identify, we're going to do a rule base. We're going to have our coding if statements, decisions. Even if we're coding, create a decision tree or thinking how to tackle this challenge or opportunity. First, we say, what is the problem or the opportunity? How can we understand it? We design an algorithm, we implement it, we compile and run. So the formalization takes all this part, and then we go and run with the algorithm and we try it. let's try and create something with the microbit that involves computational thinking 1.0, and it's going to be a jump detector. Before I jump to make code to think about the microbit, I want to invite you to do the following. You're with your students, you want to get them to use machine learning, but before even you start tackling 1.0, ask them, if I want to detect that something or someone jumped, what could we do? And invite them to forget any jargon or technical terms. That's why I didn't even jump to make code yet. I want us to think. Imagine that is me, the one that is jumping. What could I do to identify that I'm jumping? Because I'm sentient. Maybe I can count. You can say, oh, I jump again, and I can keep count if I want. Maybe it's not me. Maybe I just want when an object jumps for whatever reason, then maybe I can use a light sensor. Maybe I can use a pressure sensor. Maybe I can use a sound sensor. There are many different approaches. And embarking on this quest to start thinking how to achieve this solution, it's going to help the process. It's more important than the code itself. But now let's go to make code. I'm going to go to make code, and I'm going to open in make code. Got it. And I'm going to open a new project, Jumpy. Let's call it Jumpy. So I'm not going to explain the fundamentals of make code, but maybe you're new here. Don't stress. It's going to feel comfortable in a moment. We also have sessions, and there are lots of material that can guide your microbit. And on the slides, I'll be sharing the slides at the end of the session. You're more than welcome to apply all these concepts and to reach out to me. What I'm going to do now is to get rid of this block. And all I'm saying is I have a forever block. In my microbit, I'm going to use the emulator that I have here, not the one I have on my hand. I'm going to use this one. So for now, we start with that. And we're saying our code says forever. For as long as something happens, do something. What is that something? Show me something here. We can have now the ideation we had before, bring it to code and the microbit and this environment. Because the microbit has an accelerometer, we can detect movement. So we can detect when it moves up and down, and then maybe that's what we do. And moving the microbit up and down is going to be providing an input, a sensor input, something that we're giving or the environment is providing to the device. In this case, we're going to go and check what is that input. And we have many different inputs, but the one I want to use is this one that says acceleration mgx. So forever acceleration mgx doesn't fit, and that's because this block doesn't quite go there. We need to find a piece that fits this puzzle. Let's think about this block. It says acceleration mgx. Then it's confusing what this can be. You and your students can hover over the block, and it's going to give us some explanation. If you right click and click help, you're going to have a lot of information about the block. And I highly recommend for you to view and to share with your students these videos of how an accelerometer works. But we know is that mg starts for milli-g, which is 1/1000 of a g. Great. So now we have an idea of what this is. We're going to get a number that is 1,000 of a g. Great. If I get a number, I can go to basic and say I want to show a number, and that number is going to be the acceleration in milli-g. Great. Then I see now my microbit, my emulator is not moving, so I get a 0, and it gives me an AX0. If I move it, I start getting a number. So this works. I know that this works, but I don't have full control. I don't know if the X is properly because the microbit moves in a weird way and the number scrolling is hard to read. I get this here, but in a real microbit, I couldn't read it. So I'm getting closer to solve the problem. I think this is the right tool, but I need to find a way that the microbit is constantly sending information to the computer and charting what is happening. That is going to make it much easier. We do that. I'm going to get rid of the show number and I'm going to access the advanced area. And in the advanced area, I have this, the serial connector. I'm going to select this one that says I can name because I want to have X, Y, and Z. That'll be great. And I can put my block here. Let's try. So I put this here now. And I can say that forever, my microbit is going to be sending information via the cable to the computer, and it's going to be labeled as X, and that information is going to be the milli-Gs. As you can see, there's nothing happening on the screen right now because I didn't put anything on the screen. But if I go and click on the Show Data Simulator, then now I see my microbit and I see a representation of the x-axis on a graph and the values scrolling. So if I start moving, I start getting some information, still a little bit tricky to figure out, but we have it. Great. So that's very good. What if I duplicate this? And now I have the X, I have Y, and I duplicate, and I have Z. Perfect. So now I have the three. Let's take a look at them. And let me see. Sometimes it takes a little bit longer. It's thinking. Let's go here. Now I have the three graphs. And when I move, I kind of get it. I kind of get it. Do your students get it? Do I fully get it? Maybe, maybe not. So let's go to the next step. Is I have a long cable here. I have a microbit. I'm going to download the program to the microbit. When I download it, so we should see nothing on the microbit, but right now we have the light at the back that is blinking, meaning that we're getting this program into the device. Is erasing what we had before. The microbit only holds one program at a time. So it's making that change. And what I expect to happen is that if now I'm using the microbit, I have more control over determining if I'm going X, Y, or Z, and we're going to have to make some decisions. We're going to have to set some rules because we may have some issues. Maybe some of our students are doing this. That seems pretty good. What if they do this? How does that change? What if they start like this, or like this, or like this? Then we need to agree in how we're going to measure it. But let's start by holding it like this, and we try and identify clearly if the X, Y, and Z axis match our expectations. So right now it's downloaded, and we have something new. It says show the data on device. Not the emulator anymore, but the device. So I have it here. Let me put it here. Camera. I'm going to go. Perfect. So the X is very clear. We're getting some more movement in other areas, but it's very clear. If I go up and down, oh, now Y is extra clear. And then I'm presenting the Z. Let me put this a little bit higher. Perfect. But now remember, you need to talk to your students to decide how they want to hold it and what is going to be the first idea. So we're doing very well. We understood. And then if I hold it like this, we want to go with Y. Great. Very good experimentation. Let's go to the slides for a second. And all I have here is that I have that information and we ask about these concepts. In the slides, it's going to be very important that you will see speaker notes, and those speaker notes, they have ideas for you to work and how to understand some of the concepts that I'm explaining. There's information there. So we did that, but now we're going to do more because we wanted to make the jump detector. This was my exploration. I only need the acceleration in Y. And what we're going to do is I'm going to ask forever and say, is something jumping? Show me an image. And if it's not jumping, show me another image. Because I'm using those questions of if something happens, that means that I'm asking a question. I have a conditional. I have an if statement. So I can go to my logic and select an if. And I want to say, if jumping, let's add, I usually add something that I think looks like a rocket, but it doesn't look like a rocket. Today, like a spaceship. Yeah, maybe spaceship. Perfect. So spaceship is jumping. Otherwise, I'm going to put a heart. So just something simple. So this is going okay. I'm setting my idea. I know what I'm going to be measuring. Now I need to find what to add as a question. What am I asking? I'm asking if the microbit is going higher, is jumping. How can I change that jumping? And how can I think about computational thinking 1.0? So if it's at rest, is at 9.8 Gs. But if it's jumping, it needs to be going higher than that. So let's try that. So we're going to say if my acceleration on the axis y is greater, then we said that is 1,000. Let's make it a little bit bigger. Let's put 2,000. So we need to make it a little bit harder. And let's see if this works. I'm going to download it. So we download the program. We have the microbit on the screen, and we have the heart. It's not jumping, not jumping. Now it jumps and it shows and it disappears. We can say, you know what? Be nice to me because I'm slow. So keep the image maybe for a second, and let's try and download that really quickly, and we experiment again. So we have this heart, we jump, and we see the rocket, and then goes back to rest. So what we did there, we satisfied the idea of creating a jump detector using computational thinking 1.0. We thought about all these concepts and we created a program, and then we see that how we formalized the problem, how did we design the algorithmic solution that we ended with, and how we implemented that in a phase program, and how we tested it. And we have the ideas of decomposition, pattern recognition, abstraction, and the algorithm creation. Great. No machine learning yet, not CreateAI. The masses are going crazy. Herman, where is the AI now? Let's evaluate. We're going to see first, we jump to machine learning. What do we think? What is the different approach in machine learning that is not being explored with our computational thinking 1.0? In this case, both graphs were very similar. And what we're saying is that data is what is ruling everything. These systems are data driven. And in these systems, what we need to do, we still need to describe the problem or the opportunity. And then we need to figure out what is the data that I want to collect. Is it numbers? Is it image? Is it sounds? Is it what? What do I need? Is it a traffic light? Is it a sensor? What do I need in order to collect to satisfy my problem or opportunity? After I collect it, I need to process that data, meaning I need to filter it, I need to clean it, I need to label it. I need to give it labels so it can be in different buckets, so it can be categorized in that way or predicted to be the action one of those buckets. But I need to make sure also that the data is relevant. Maybe I need to take out some data that is not so relevant while I'm collecting, or maybe I need to create systems to avoid collecting wrong data. And then we go and train. The system learns using supervised and supervised or reinforcement learning, any of these techniques, in order to create the model and then provide us the algorithmic representation. Great. We saw 1.0, we saw 2.0, we created a process with 1.0. Now, let's create the jump detector in MakeCode with computational thinking 2.0. The important part that I'm not even going to jump to MakeCode, because how do we do this? We will need to capture jumping information, rest information. Where do I store that within the microbit? Especially, how do I collect that data, store it, determine what the model is, and use it in the future. I don't know how to do it within MakeCode and its capabilities. That means that MakeCode is not necessarily meant to work as computational thinking 2.0. And that is why the Microbit Foundation has created CreateAI. We've had before, we used, for example, a bridge created by Steam Labs that helps us connect the microbit to machine learning models. But this one has many benefits. The main one is that it's extremely simple and very robust. Hopefully, I get to struggle because I've seen that sometimes there are some things that go wrong, but I'll provide you with information on how to overcome those challenges. So let's go to CreateAI. We have the link here to CreateAI. The site is very clear, very approachable. Remember, I'll be sharing the slides, so you're going to have access to all this. But I assure you that if you understood the concepts that we saw, the rest of the process is very easy to follow within the site by you and by your students. Now, before we jump, we're talking about version 1 of the microbit, and we're going to think is that there are two concepts to keep in mind. Is that we're going to use V1 for now. The Microbit Foundation recommends V2, but I'm going to tell you why you can use V1 and how far we can get. And if you have issues, I provided at the end, the Microbit Foundation has a troubleshoot guide, and the troubleshoot that I do, which I may have to do today, is sometimes I just need to disconnect and connect again. They're all saying, just turn it on and off and see what happens. And sometimes when it doesn't fix it, I go to MakeCode and download different code and come back, and it has always worked. So there's the challenge, but the possibility of something going wrong is there, but it can be easily addressed. Now, I have 1, 2, 3, 4 images here that I have them here. So you have the peace of mind that they exist. They have some comments, but they're all part of the process. And to show you the process, I'm going to go to CreateAI. So this is CreateAI, great resource, many great ideas, a video how to work, lots of steps. The first thing that I want you to focus on is that I am not logged in. Is because you don't need to log in. Your students do not need to log in. So that saves the pain of passwords and all these things, makes things a little bit easier to use in the classroom. If we click on Get Started, then it says you want to continue a save session or open last session. It's saving in the browser, or we can save in a file. But we're going to start with something new. Let's start from scratch. So what we want to do is we want to get to our jump program, but using computational thinking 2.0, using machine learning. Let's think, how do we start? Do I go with all this information? I have to save many different things, but then this you recognize as the graphs I have in the slide deck. It says your microbit is not connected. Perfect. We're going to connect. Tell me how to. I click on connect and said, before we start, please have these things ready. Have your microbit. This one is a V2 because it's not flat at the bottom, but has the notches. We're going to start with the V1. Have a computer that has the USB port where we connect things and has Bluetooth. Have the USB cable and the battery holder. If by some reason your computer doesn't have Bluetooth, there's a way to connect with radio. The difference is you're going to need 2 microbits instead of 1. Going to go with this process. I want to go with this process for different reasons. It's very likely that you have used radio at some point, but it's very unlikely that we all have used Bluetooth. I haven't used it that much, and this I find that is a good way to get familiar with it and to get exploring. I'm going to click on next. So it says connect the USB to the microbit. Done. It's connected. Perfect. We go next. And then it says, oh, you're going to have a pop-up. You're going to have some information in the pop-up that you need to select and click connect. That sounds clear. Click next. That is my pop-up. It's going to change if you're in a Chromebook, in a Mac or a PC, and depending if you have a dark mode set or not, this is going to be white or black, and then it's going to look a little bit different. But in all of them, we select, and when I select it, I have my connector label enabled. I click connect, and then let's see if it gets confused or not. This program might take a little bit longer because this is flashing all the information and putting no information on the microbit. While we wait for this, I'm gonna have a commercial, but I'm not selling soap or anything. Is that what I want to do is on the slides that I have is also my email. If you need support, if you have questions, please don't hesitate. Send them to me. Maybe we can set up a meeting and talk about your needs. We're a nonprofit. We offer teacher training for you and your colleagues for free. We have open sessions. So please do reach out. I'll make sure before we end the session to share the slides so you have access to all that. See, no Ginso knives, no soap, no shampoo, but just support. Perfect. This now starts looking a little bit different. It says, so you finish that, you're going to disconnect and connect your microbit to a battery pack. I have my battery pack, but because I do this quite often, I have a Dollarama battery pack, and then I don't have to be worrying about batteries, and it works for me. So I'm going to plug it in. Now it's plugged in, and when I plug it in, I get a pattern of lights on the microbit. I'm going to click next, and it says, you should be seeing this pattern. So I was always saying, I always see the same pattern. I don't understand why this happens. And then I got it. If you're in a classroom and you have 10 microbits, 10 computers, or 20 microbits, 20 computers, then it's going to be very important for your students to make sure that the patterns match. You don't change the one on the microbit, but you can easily change the one on the screen. So far, this is a little bit different, but kind of cool, kind of okay. We click next, and now is the different part. We're going to connect the microbit to the computer using the USB. So once again, we click next. We get a window that looks the same, but now this is different. I select it. I click pair. Then this connection is happening, and I want you to look here at the bottom. And then now I have the live connection to my microbit. So the process, as you saw, everything is on the slides, but you don't need it because it's right here. It's going to take you by the hand, and then we're going to explore. What is the gotcha? Is that the only thing that we're using at the moment on CreateAI to train is the X, Y, and Z axis. That is a gotcha, but it's also a plus for the moment because you don't need to worry about sharing any sensitive information because all we're doing is moving our microbit in different ways. Now, if we're going to do our jump, let's do what we did before. I have an action. I'm going to call this one jump. So I have my label and the icon that I chose that is there. I can change it, but we need to record. I can click record. I'm going to put the microbit here. I click record. It gives me a countdown, and then I jump. Perfect. So that's one. There's one option that I really like. If I click on the three dots, I can click and record for 10 seconds. So I'm going to collect more samples. I click on that, and it says ready, ready, go. And then I start recording, and maybe I stay static for a little bit because I got distracted, and then I keep on jumping. So your kids are capturing different jumps and different things. That's the first part. We identify the data. Is the movement, the accelerometer on the y-axis. Remember, then we need to label. We label it, part of the second step. Then this is a really cool step. You have this here, and you're going to go with your students and say, these are the samples you took. Do you think all these samples represent jump, and why? Sometimes it's very easy to understand. Sometimes it's a little bit harder. But if you start looking, they're going to say, this doesn't look like jumping. And why? Then they're going to say it's because what we see, the Y, is just static. Okay, so we can get rid of it. So we reduce the bias. The data bias, the data that we're providing needs to be meaningful and representative of what we're trying to evaluate. I'm gonna get rid of this and this. Great. So we have one. Let's get another one. We need at least another one. Let's put, I call it sleep. Sleep. And I'm going to collect 10. And the sleep, all I'm going to do is I'm going to put my microbit is going to bed for a little bit and record the 10 examples. And it's just laying there. You can toss and turn if you're having a bad night, but we don't move that much. Then it's recording all the examples, and this is pretty fast to get 10 examples. It's done. We do the same exploration and ask them, where do you see the why and what do you see what is happening with the other ones? That's the idea. This opens a conversation to explore so much more than machine learning. We capture 2 different examples. Now what we're going to do is we want to train the model. So we have our examples, then we proceed to training, and very easy for us. We click train and we wait. And then the program is using the examples, not that many, not thousands of hundreds of thousands as we have heard. And that is because this is one of those programs that is meant for education. And then it has been modified in certain ways so it uses less examples. Now we're done. We see that we have our icons. We have information that says, what are we recognizing? We have a bar, and then we have a percentage. How sure are you that it's doing jumping? And then it shows us one block. Oh, this shows make code. So we have blocks. We have a different way. What else we can do? We're going to explore that. And then we see this one in green, sleep. Oh yes, I put the microbit on my lap and it's sleeping. If I put it here, let's put it here in camera. So I have it here, sleeping, 100% accurate. Great. And it gives me the icon that I'm looking for. So let's see if the jumping is working. I'm going to put it like this. And it says, let me see, what do we get? It says, hold it. So it's in camera. We're getting sleep. Why are we getting sleep? Is it getting jumping? So it's getting jumping. That's pretty good. And is it getting sleep? It's getting sleep. So in this one, we were super lucky. The data that I collected is really good. But many times, you're going to have a challenge. And remember, in our cycle, we need to identify things. Is that sometimes, oh, there, it told me that it was jumping for a little bit, depending how I hold it. So we need to ensure that our system, we can enhance now that we learn. We could provide more data. Maybe the data I provided is so good that it always identifies that it's jumping, but we can add one more that is stand. And we're going to record, and that we set our microbit and we record, and it's very similar to the sleep. And we stand, and I'm moving a little bit like NPCs, like we see on video games. The characters always move a little bit because I think humans, we always move a little bit also. So they're trying to emulate. Let's do that with our microbit, and we see gentle movements, and it captures our data. And let's train again, because now we have more labels, more data, and all of this needs to be accounted for. Then we train the model. We have these 3 different things. And now stand, perfect. Jump, great. Sleep, sleep. So the fact that it works, yay, great. But what is most important is, how did we get here? What is the process? What are the uses? It doesn't mean that everything needs to be done with machine learning, but then we saw a way that it can help us approach problems and opportunities in a very dynamic and interesting way. Now we have these blocks, correct? I can make my program. So let's make our program. We have a block here that says edit and make code. We have our model. What program can we create using this model? Maybe we have an alarm when something happens. Maybe we're tracking the number of jumps and slips and stands. We're tracking it by time or by counts. We can do any of the regular coding we have. So let's go and let's click edit and make code. And we have our wow. This is how far V1 will take us. It says incompatible device, you are using a V1 microbit, you need a V2. The important part, we're going to explore V2, is that see how far we got. We have our untethered microbit communicating with the machine and then giving us ideas and concepts to explain and learn about data, about uh, rule-based systems, and about machine learning. It is great for education. So if you don't have a V2, it's fine. But if you have a V2, let's go to the slides and explore what's happening. Why can't we use V1 for what we want to do in make code, and how can we address it? So I'm going to click here to our slides, and we were in this process. We got here, but we're going to see a few steps. We're going to do a mini recap. The first one, remember the collect, is when we decide what data we're collecting and we start collecting those. We process by selecting some data and deselecting some data in order to have unbiased data that is representative of what we want to model. And then we train once we're ready, and at the end, we evaluate. Great, we did all that, but now V1 can do some things and it cannot do some things. The first one it can't do, it doesn't have enough capacity to store data. V2 has the capacity to store data. You can store data, is one of the things that it can do now. So you can go outside and you don't need to transmit via Bluetooth or radio in order to save the data. The data is stored within the device. Great. So that's one of the things we saw we can work without that, but we'll see what are the benefits. The second one is that the V2, the processor, is powerful enough to process the machine learning model, to take that data and to identify and to do all that it needs to do in order to do the prediction. The V1, it can't. But as we saw, it doesn't need to because it gathers the data, sends it to the computer, and the computer makes the processing for us and it provides the prediction. So that's an important part. What it can do is that it can collect the data and transmit it to the CreateAI app, as we saw. And it can, the model prediction can be seen on the Create app. That means that what we're thinking about education and teaching, we're golden. That's great. We can use the V1, not a problem. Now, this is the error that we get. We're going to go past this in a second. But now let's see what is the process now that we need to use the V2. How different is it going to be from what we created before, or how similar? There's good news, is that the process is exactly the same. We don't need to worry about learning anything new. The thing is that at the end, we're going to be able to use make code and expand on our program. So let's go to make code and let's do the example now. I'm going to go back. Let's go to CreateAI. Can I go home? Let's get started. We're going to make a new session. Perfect. So I want to disconnect the microbit, and now I'm going to connect the new one. We're going to do the process. I'm not going to explain it that much. It should be pretty straightforward, I hope. Let's try and see. I click on connect. Failed to reconnect. That's okay. Let's click reconnect. Now it says, oh, you're going to do this. And if you have problems, this is troubleshooting, or you want to use radio. No, we want to use now the V2 with the Bluetooth. We go next. Same step. We connect our microbit. The microbit V2, something important is that it's going to have the yellow light that is transferring information, but also the red light that says, I'm alive. We click next, and then we get this window. It says we're going to pair, we connect. As you saw, it downloads the program much faster. So it's a faster processor, so the process is faster, but it doesn't mean that is the other one I still love my microbit V1, so I defend it. Now we're going to disconnect this and put it with the battery pack. Good. This is going super well. Then I should have the image. Perfect. That's the image that each microbit is going to get a different one to mirror with what we have on the computer. The image is matched. We're happy. We don't have anything else so far. Go next. We're going to pair now the Bluetooth, and we pair. Let's see if everything goes well. Perfect. So we're getting this. Now we know we need to do our jump. And I'm going to add another action that is, this is stand, and another action that is sleep. Sleep a turtle? No, poor turtle. Let's be this. And let's record. Going to grab my microbit to record the 10 seconds. And we're going to do our jumping. So let's jump, jump, jump. We can do the jumping fast or do it slow. It would be great to have lots of examples that are very inclusive. Then we come and we analyze this. It's a different jump, so why not? But we're seeing different graphs, and then the students can make predictions of how that works. Then we're going to make the stand. This is easy. We just put 10 seconds, and we have our microbit just standing, chilling here, just getting all the information and getting ready to explore and to send. So let's wait, and 10, and we're done. And sleep. We're gonna record for 10 seconds our sleep. We're repeating so far, nothing has changed. We're doing the same process. It's just because in the previous one, we figured out that having the stand is gonna make our program a little bit more reliable. Then now we say train the model, and then it's training the model, nothing to do with the microbit at this moment. And sleeping is standing and is jumping. Great. Now where we fail is when we click edit in make code. Because we have the V2, we shouldn't have that issue. Gonna click, and then we have now make code open. There are a few things to keep in mind. The first one, it shows V2. This happens normally, but the big one is that we have a new set of blocks called machine learning. And those machine learning blocks are few but very powerful, because these are the ones that were created for us. So when it's jumping right now, we just have show the icon, but we can do more things if we want. And the other part that we have is that we can go back to change our training or to modify our labels or the data that we capture by clicking on this arrow, takes us back. So if we have this, then now we can do the program that we want. We can go and recreate something like this or any other type of program. And that's the story of CreateAI, and how should we think about it, and how can we approach it to have our students think about computational thinking and how it takes us to data and machine learning. Let's go back to the slides. We're almost at the end. So we have the process. It shows us that we can do this. We're super happy. And I'm going to be super happy because I'm going to be asking you for feedback. Please, please, pretty please, when you can, fill a survey with a nonprofit, so we don't charge for our services. And then we want to keep on helping you on providing this information, this type of services, and the survey links are very important to us. I'm going to give you the slides as soon as we finish with the slides. Two more. It was three more. I added one for the Microbit Foundation that takes you also to CreateAI. They have a great glossary of information for you to browse and to share with your students. And they have troubleshooting. We didn't have problems today. Usually I have problems. And I like when I have problems because we get to debug them live, and I get to struggle and just feel aggravated. But then that gives you the confidence that we all struggle when things go like this, that nothing goes wrong. That usually is not the case, but the troubleshoot guide is very good. But remember, first two step, disconnect, connect. Second step, download a different MakeCode application to your microbit. Gonna be okay. The last thing is all the other things that we offer is that we have teacher and pre-service teacher training for free. If you and your educators, you want to be trained online or in person, if we can make it there, sorry, we'll be happy to get in touch with you. And we have these other things, and this is my information if you want to reach out if you have any questions. And now that's the real end. Let me copy the link and I'll paste it in the private chat so Mr. Cran can share it with all of you, because I don't have access to sharing there. And I'm going to put this. So Mr. Cran, if you can help me and share this with the chat, I'll appreciate it. And that's all I have for you today. It's a really interesting concept. It's a powerful technology. It helps you talk and explore many things with your students. I thank you very much for joining us today. I have one more session that's going to be Experience AI, talking about AI and safety material that you can use with your students on AI, now thinking about safety and terms of service. That's the first one we're going to explore. Really interesting, terrifying. I always run from terms of services. That's it. If you have any questions, please let me know. I'll remain here for a while until Mr. Grant tells me to stop being here. If you don't have any questions, I wish you a wonderful rest of the day, and reach out if you have anything that you need from us. We're here to support you. Not keep jumping, standing, sleeping. Good. How did I get to highlight the portion of the text? So to highlight like this is a tool that is called Screen Brush. I find it very useful for presentations. Sadly, it's not available for PCs. It's available for Mac, and I think it's $5 if you want different shapes. or it's free if you just press one key and then you can draw things on the screen. It helps focus, especially when there's a big audience or we're remote and then there's not easy to see. It's called Screen Brush. Let me see, it should be this guy, Screen Brush. Really, really useful. Yeah, I like it too. It helps me a lot because it's hard sometimes when the screen gets really busy. It's very easy to determine where we're at. Yeah, I think we can wrap it now. It should be fine. Maybe I put that person to sleep. We never know. Yeah, my pleasure. Have a great day, and I'll see you around maybe. Have a good one. Bye.